All right, number 6. We are given f of x is equal to negative x squared plus 2x plus 15, all divided by x plus 3. And we have 5 parts. First, we want to find the domain and write it in interval notation. So we need to find restrictions. Since it's a rational function, we focus on the denominator. Set it equal to 0. So the x plus 3, set it equal to 0 or not equal to 0 if you want. And then we will get x cannot be equal to negative 3 because you'll subtract 3 and move it over. So if we plug in a negative 3, we're going to get 0 on the bottom. Dividing by 0 is a problem. So putting the domain in interval notation, the way I like to do it is write a number line. This is going from negative infinity to positive infinity. We're going to remove any point. So we'll just say that this is negative 3 right here. And we're going to put an open hole. So it's going to like make a break. So we got two pieces, negative 3. So we're going from negative infinity to the left side of negative 3. And then we'll go on the other side. This little union symbol means connect these two, like if this was a broken piece, to the other side of negative 3 up to positive infinity. So that's going to be your interval notation. I don't have the union, so I'll just do a comma. I'll say union. Oh, I do see the union symbol. I didn't see it a while ago. Now I see it. It's right there. That's why they won't accept it. All right. Part 2, we're going to simplify it. Simplify the rational expression. So I'm going to see if the numerator will factor. Now, one thing you want to be careful of, don't factor with a negative out front. So think of either factoring out a -1 or multiplying through by -1. You have to do it on both sides. So I would just say factor out a -1. And focusing on the top, this will be a -1. And then this will become a positive x squared. This will become a minus 2x. That will become a minus 15. Whenever it's a negative out front, the factoring process kind of messes up. So if you factor out the negative, you'll get the correct factors. Now we'll think about 1 times 15, which gives us 15. Factors of 15 are 1 times 15, and then 3 times 5. We want to subtract to get a 2. And if we subtract 5 and 3, we will get a 2. So I'm going to leave this -1 outside, do 2 sets of parentheses, and then we'll have the x squared, which is split up, a 3 and a 5. And we want to add these together or subtract them so that we get a -2. So that means the bigger number needs to be negative, and this would have to be a positive. Okay. So this is the numerator now over the x plus 3. So the x plus 3 would divide out, leaving me with a negative x minus 5 quantity. So we will say f of x simplifies to, I'm going to do a negative parentheses x. So I guess I'm going to have to distribute because it won't give me a parentheses, so negative, and then that would be a plus 5. Plus 5. When I distribute the negative, and then we still have to remember x cannot be -3, okay, from our previous step. So that's what this is saying, -3. Even though it canceled out, you still got to remember that x cannot be equal to that number. We're going to identify vertical asymptotes. Okay, so normally what makes the denominator 0 is a vertical asymptote. However, when this happens and it cancels out, it no longer, so like if we were doing a graph at -3, 1, 2, 3, A vertical asymptote will be like a dotted line that the graph cannot cross. Well, when that cancels out, instead of having a dotted line, we are now going to have a scenario to where we have a hole in our graph. So this simplified function, which is negative x plus 5, this graph would be up 1, 2, 3, 4, call it 5. We'll call this 5. And then our slope is negative 1. So we'll go down 1, down and right. It's going to give me a negative slope. So I'm going to go up and left. So up to 6, left to negative 1, up to 7, left to negative 2, up to 8, and left to negative 3. There'll be a hole right there. And so instead of having a whole line that the graph doesn't pass, it's only going to be a hole in that one spot. There'll be a line going diagonal negative slope, and then there'll be a hole right at x equals negative 3. So vertical asymptote, in this case, there's not going to be one because it got divided out. All right, we're going to identify any other values of x other than those corresponding to the vertical asymptote for which the function is discontinuous. There's not any other values of x other than the negative 3. So x is discontinuous. So now it's saying it's not an asymptote, it's a discontinuous point or a hole, and that's still at negative 3. And then, and once you identify the graph, so what happens is once this gets simplified, when it gets reduced, we're just looking at a linear function, negative slope. So this is not linear, this is not linear. This is linear, but the slope is positive. This is linear, but the slope is negative. Looks like this is counting by 2's, and so right between 2 and 4 is where we would have negative 3, and that's where your hole is. So D looks to be the correct graph.